I would like to have a quick review of what we have learned in our previous session, and then we'll move on to the next topics. So let me just go quickly to. So what we talked about is what is system design, what are systems, and what are the different components or design consideration that we make use of when we design a system. So this is what we discuss. And moving on to our first model, that is client server model, we have seen that how a user will send a request, like user knows that he or she has to access www.myweb.com through web browser or mobile app. And that request will go to first to DNS, domain name system, and domain name system will provide a public IP address of the server that hosts this website. And the server will, like, you will send request to this particular IP address, and a request, maybe a example request that get user with ID 12, and that server will send you the request back to the client in either HTML, JavaScript, or JSON format. The server will be having all the application logic, database, and cache inside one single server. So we found that okay, there is an issue with web server, and then we move to separating the two layers, like a data layer and a web layer. So we have seen here, we have just separated out the database, and we also discuss about what are the different types of database, relational, non-relational, and when to choose a NoSQL or non-relational. This is what we discuss. But with this design, uh, there is still one more problem. Even though we separate out the database layer, there's one problem is still there is both web server and database, both are still single point of failure. So to achieve, means to see to it that our web server should not go down, or even if it goes down, we should keep on providing the same service to the client, even though server is going down and even the database is going down. So this is something that we will try to look at it today. And let me move to my next chart. So first we'll look at how we will solve the single point of failure at web server layer. So here there are some changes that we have done. For example, if you see now instead of one web server, now there are two web servers, and they are put under an auto scaling group. And it is these two web servers are in a VPC, virtual private cloud. So I'll let you know what exactly this means. And there is one more component we have added called load balancer. So on left hand side, the entire process is same, but what we are doing right now is we are putting two servers in a virtual private cloud. This private cloud having these servers so that these web servers are now not accessible for the outside world or over the internet. These are under a private, we can say, uh, a private cloud or private network, and it is also an auto scaling group. What does it mean is, first thing, these web servers, as I mentioned, they are not now available over internet because now they will have a private IP which is accessible only in this VPC. So you cannot access it from outside this network or this cloud. And second, the auto scaling group is that in auto scaling group, you can define, okay, minimum server I need two and maximum server I need six. So in case if the number of users or the traffic from the user increases, for example, now we have one user, maybe it becomes 100 or 1,000 user, then all those requests should go to these web servers. But two servers are not good enough to serve those all the requests. So in that time, the auto scaling group will do is it will add more servers to this pool of web servers, and it will, according to the increased load, it will go up and down. Like it will add more servers, it can reach to the maximum limit that we have given, that is 6 servers. And as the again, whenever the request goes down, like whenever traffic will go down, it will again come back to two, because that is what limit that we give. We'll get into the details of these, but just to make sure that you are aware of what is auto scaling. Auto scaling is according to traffic. If it is the load is increasing, the requests are increasing, this VPC layer will increase by adding more server, and it will again go down if the requests are going down. Okay. And one more thing that you have observed, that now the web server has private IP address. As I mentioned, because they are part of private cloud, it will not be accessible to internet. Sorry. Now, because they have a private IP address, and maybe last time we have seen here is our web server was directly accessible over the internet. When we are doing a DNS query, it will send you the public address, but public address of what? The public address of web server. So you imagine that your web server was accessible over internet. So there are chances that someone will try to send too many requests and try to bring down your server or try to put some security threats into your server directly because it was accessible. Its public address was accessible over the internet. Now, just to make sure that now we have many, one thing is that we have many number of web servers, and these web servers, like, we cannot provide one web server's private IP address to DNS. So again, the same thing will happen, like all this request will go to one particular server, so we don't want to do that. So in that case, just to see that all the web server will get equal amount of request or they will be served equally, so we what we have put is something called load balancer. The purpose of load balancer is to see to it that the backend server will get a request evenly. The request will be evenly distributed. And what DNS will do right now is load balancer will be registered with DNS, and the public address of load balancer will be given to you or to the user. When a user will send a query, this public address belongs to load balancer, not to a particular web server. What it will give an advantage is your web servers are now secure, they are private, no one can access it, and any kind of security that we need to put, we can put it at this load balancer level so that no harm can go to the web server or even to database. So the purpose of load balancer is to evenly distribute the requests that are coming in, and load balance will have access to this private IP address of web server. And as load will increase, like the auto scaling group will increase the web server, the number of web server, load balancer will automatically start sending requests to those new web servers as well because they are registered with load balancers. We will get into details, like there are multiple strategies for load balancer, how load balancer usually send the request, what are the different strategy. Maybe just to name, there is something called round robin or weighted round robin. So we will get into those in detail when we'll specifically look at the load balancer. But at this point of time, what I want to mention is load balancer will do the work of sending the request evenly to the web server and controlling all the security threats or any other uh, issues that are coming in from the user. It will be blocked at the load balancer level itself. Now you may ask that load balancer itself can be a single point of failure, and that is true because again it's a one single device on which we are, but there are strategies where you can have active and passive load balancers at this layer, so that also we'll look at it later. And you can also see that now even database also a single point of failure. We have not resolved anything related to database, but I just want to make sure that at least this workflow is clear. And one more thing that I mentioned on the top, vertical scaling and horizontal scaling. So right now what we are using, adding multiple web server, is called horizontal scaling, where horizontal scaling, also called as scale out, allows you to adding more server into your pool of resources. So what we are doing is we are adding more servers and trying to send requests to it. So adding more servers means more machines, means it's a horizontal scaling. And vertical scaling means it's a single machine, a single web server, and it is also referred to as scale up. That single machine, we are just adding more power. Means we'll add more hard disk, we'll add more CPU, RAM, and all those things, but it's still a single server. And it may cause, like, you can reach to, okay, maybe highest configuration of a machine, but there is still a limit to it. And still it will be a single point of failure. And also I mentioned load balancer here is load balancer evenly distribute incoming traffic among web server. So I hope this is clear. So I'll just repeat the workflow. We'll again go to www.myweb.com. The client will ask the IP address of load balancer to DNS because load balancer IP address, public IP address is registered with DNS. DNS will send that public address to your client, and then using your client, you will send the request to load balancer. What load balancer will do, it will check the web server which is healthy. Now, what is this healthy means? The web server who's responding to your request. It will keep on, like, there is one responsibility on load balancer is it has to keep on checking the backend server which server is responding fast, which is actually giving response, or which server is down for now, at least for some time. And it will accordingly, it will send the request to those web server. So your request will go to web server uh, according to the strategy. And that web server will do some application logic, will extract some data from database, and it will give you response back to the load balancer, and load balancer will send that response back to your client. So I hope that this is clear. And just to make sure that if any web server will go down, what the auto scaling will do is it will immediately run another web server, and that web server will immediately available in your VPC, and then load balancer will come to know, okay, there is one more web service available, so it will immediately start sending request to it. So that will be internally taken care by auto scaling group and load balancer. All right. So any question on this?
Yeah, I have one question, Shashank.
Yep.
We have two web servers here. Like if, like you said, if any one web server is getting down, so it will routes the traffic to the server one, or it will create like it will the availability is there of web server three, so it will routes that traffic to the server three.
Yeah. Good question. See, whenever a web server will go down, suppose web server one will go down, temporarily the traffic will be moved to web server two. Okay, the second web server will have that traffic, and meanwhile, the auto scaling group will do is it will try to spin up a new web server at the place of web server one, and it will put that server in the place of web server one. So till that time, the traffic will go to web server two, and once the web server three is available, immediately load balancer will come to know, because of load balancer will do continuously health check of servers. So immediately it come to know, okay, web server three is available, and it will start sending requests to it. But till that time, web server two will get all the requests.
Okay,
Hope
thank you.
that is clarifying. Okay. All right. So if there are no more questions, let me move to next. So what we have seen right now is the web layer or web tier, which we have expanded to see to it that, see, by adding more web servers through auto scaling group, it increase the availability of your service. If you imagine now in a previous design, web server one, there was only one web server, and if that goes down, your service will go down. That means your system is not available. User cannot access it. But by adding it in an auto scaling group under VPC, by putting a load balancer in between, now your system is more available, that even one server goes down, the second server will take care of it, and another server will automatically get added. So just imagine your system has become more available, and even I can say reliable as well. But there's still single point of failure on the database tier. So let's see how we can solve that. I am moving to the next chart. The next chart is talking about database replication. See, I have just cut down the left hand side. Right now we can just see there are web server, three web servers are available under VPC, and on the right hand side we expanded the database layer. So what exactly we are doing here? So instead of having one single database, we split that database into two different types of database. One is called slave database, and another is called master database. So you can see here is, see, for any application, just imagine if you are looking at YouTube, and YouTube mainly there are people those who visit youtube.com to watch videos. So the ratio between the people who actually upload the videos and the people who actually watch video is very high, maybe 1:100 or 1:1000. Okay, so that means there are more of read requests. Like those who watch, there's actually requesting video. Like when you click on any video, the video gets uploaded in your browser slowly, slowly. So that means you are reading those videos from the server. And writing means when you're uploading your own videos to your own YouTube channel. So these are read and write requests. So mainly these are actually, there is a ratio like 1:10, 1:100. Like one is the actual write request and 100 is read request. So that is the ratio between them. So what this is one of the strategy I'm talking about of database application, but there are multiple strategies for databases, and we'll discuss that later. But I'm just trying to convey the information that how we can improve the database layer itself. So what we are doing here is we created two different types of databases. One is master database, one is slave database. And the slave database are more because there are more read requests that we get usually. So there are more for read purpose, there are more slave database. So you can see now there are three. It is just numbers are just random. You can look at this number as maybe there are 10 or 20 slave database. So that is possible. But I'm just putting here three just to explain the idea behind it. So these three slave database are whenever user will try to read any information, this read request will go to a slave database. So you can see now the read requests are passed on to a slave. But if you are trying to add something, if you're trying to update something or modify, or you want to create something new, in that case, like what we usually do in database, insert, delete, and update, that request will go to a master database. So just I'm just giving a quick overlook of this, that what is the purpose of it, but how exactly the main question is that because the write request is going to master database, we need data to be in sync for slave database, because someone is writing and someone is reading. Suppose I'm writing something to my database and I want immediately some user is trying to read what I've written, what I have, maybe a video that I have uploaded, someone wants to see that video immediately. So how that will happen, because they are not in sync at this point of time. So what we do is something called database replication. So whenever a data in master database, anything that is written, it will immediately get replicated to all slave databases. So that all the information that is written to a master database, it will immediately available on slave database. All right. So this is how usually most of these systems are designed in a way that slave database and master database will have different kind of request. You can say that okay, master database is still look like a single point of failure, and I'm saying yes, that's also possible. But let's look at some of the scenario. For example, here I mentioned that if there is only one slave database instead of three, if there is one slave database and it goes offline, then what exactly we do is most of the time the read request will temporarily move to master database until and unless we restore the slave database. Okay. So I'm talking about one slave database. If there is only one slave database and that goes down, the request will be moved to master database. Mostly no one will do that because master slave database will be overloaded. But I'm just talking about one use case. But if there are multiple slave database, then if one database goes down, then this read request will go to a second slave database. And after some time, this whichever database goes down, it again the read request will be set. But then again, there will be kind of replication will happen between slave database and uh, other slave database. So the replication is needed. It will be replicated from master database itself. All right. And the last thing is if what happens if master database goes down. So there is one strategy that is usually followed is the slave database will be promoted as a master database, and all the all the write request will go to that new master database, which was earlier as a worked as a slave database. So that is one of the strategy. Uh, it is sometime it is applicable, sometime it is not, because sometimes there is a master database replica is always available, so that it's again active and passive. One master database will be an active and there will be a passive database available, and there is a strategy that whenever you write a request to master database, it will also get written to a passive copy of it. So that is again another strategy. We'll discuss about that, but at least at this point of time you should know that this is one of the strategy that we use, and to make see that read request and write request are separate, so that see imagine if you're requesting something and only one server is there, so how much load will be there on that particular server. So that's why separating out read and write according to the user flow or the traffic that we get, and accordingly it will be served. So this will help to have a better performance system. What does better performance means? In this, now as because the read requests are separated out from the write request, you will get a better response, and you can have parallel requests. Like at the same time, some user can write something to a master database, some user can read from a slave database, and other users also can read from other slave databases as well. And the replication is happening every single time. Okay. And also there is reliability. Reliability, as I mentioned, that if any one server goes down, there is a possibility that other slave database will can take that request, and after some time again slave database will be restored. All right. And high availability, because we are taking care of the failures, the system will be available every time. It will be taken care, all the read and write request. So the system will be there and giving you, like for the user, giving the service that is asked for. Like if user is sending multiple requests or thousands of users sending requests, those will be served without any downtime. So these are all different strategies. So we are just looking at, first we look at the web layer and then we have looked at the database layer. But any question on this?
I have one question.
Yeah, go ahead.
Here, why we cannot create multiple master databases?
Yes. So for this, no, it is just an example. That's why I've showed that master database is a single database, but there are chances that we have multiple master database. But the question is now, if you have, suppose if you have two master database
Hmm.
and you are replicating data to slave database, right?
Hmm.
Just imagine one request coming from one user, it goes to one first master database, and then there will be a second master database to which other user requests go. You first thing you have to replicate both master database data to slave database. That's first thing.
Yeah.
And suppose master database one is getting replicated to slave database, and there are chances that to keep the sync between both the master database is needed because the data should sync to slave database immediately. So there are chances that some data may not be available immediately. So there is something called consistency. There are two types of consistency: eventual and strong consistency. Like you imagine that you watch a YouTube video and when you see that how many views are there, so those views numbers are not immediately get updated. They get updated slowly. Like you watch for maybe 5 minutes and then the number you can see it's increased. So that is called eventual consistency. So in this same way, if master database, if there are two master database, we have to see to it that that data is replicated consistently to the slave database so that whenever read operation will come, they can immediately available. But it again depend on system to system that what kind of consistency you want. Strong consistency, which is mainly applicable on financial or banking related transactions. You imagine that you do a transaction on an ATM machine, you remove some money and you will immediately get an SMS and your amount will get immediately. So that is called strong consistency where you need an immediate response. So in that case, we have to see to it that how we can handle those situations if you have multiple master database, how that data will be written, how that data will be replicated back, how the notification service will be given kind of notification to alert the user that okay, your amount is deducted. So all these things should be done. So these kind of things are there while designing. You need to consider that whether you want to master one master database, two or 10 master database, but you have to take care of the consistency between this master database. Like all the data should be consistent. It should replicate back to the slave database and it should give the right information to the user. Again, consistency we'll discuss in later, but it depends on design. It's I have just for example put it here one master database, but there are possibilities we can put multiple master. But design will become more complex, and you have to consider different scenarios when we will design the system.
Yeah. Okay. Yeah.
Okay, but definitely we will look at the database in more details later on. This is I'm
Mhm.
just giving an overall picture of how the system works. Moving on to now how our design, the overall design look like. So you can see now the design is looking like, I'm just repeating, user is accessing through client myweb.com. It will go to DNS. DNS will send you the public IP address of load balancer. Load balancer will send you a request to your web tier having multiple web servers under autoscaling group. And these web servers, all the web servers will be, if there is a read request, it will send that request to slave database. And if there is a read, if there is a write, update, or insertion request, that will go to master database. And there will be continuous replication happening between slave and master database. So this will be your web tier and data tier. All right. So I will stop here because we already crossed 30 minutes. So let me first stop recording.